All right, so this lesson extension for honors is an extension of 311 and specifically will introduce this concept of a substitution, often called a U substitution, just because we typically use the letter U when we do these substitutions. So we'll start with this first problem right here, I. So we're just going to start by well, it says examine the two equations below. So we've got x squared plus 7x plus 12 equals 0. And then we've got this way more complicated looking one, 1/2 x plus 7 squared plus 7 times 1/2 x plus 7 plus 12 equals 0. So let's start with this nice, seemingly simple one, x squared plus 7x plus 12. And in part A here it says solve the first equation. This is just a standard quadratic equation set equal to 0, and to solve this one, let's begin by factoring. So if we can factor it, then solving it will be pretty simple. So doing the diamond game approach, I've got my 12 up here, my 7 here, and I want to know two numbers that both multiply to 12 but add to 7. That's going to be 3 and 4. So my two pieces of this in factored form, my two factors are x plus 3 and x plus 4 equals 0. From there, I can just set each of my two equal to 0, and that gives me my two solutions of -3 and -4. So I've got two solutions, -3 and -4, to this quadratic equation. Okay, so this next part B, this next part says how can we use the solutions from the first equation to determine the solutions to the second equation? So from the first to the second, how could we possibly use these solutions to solve that equation? So let's take a closer look and compare the two. X squared plus 7x plus 12 equals 0. 1/2 x plus 7 squared plus 7 times 1/2 x plus 7 plus 12 equals 0. So I'm hoping you are noticing some similarities. We see this plus 12, plus 12. In my first equation I have x squared. In my second equation I have this whole chunk, 1/2 x plus 7 squared. And then instead of plus 7x, I have plus 7 times this one big chunk. So hopefully you are seeing this repeated piece, 1/2 x plus 7 here, and 1/2 x plus 7 here. But other than that, everything else is the same. I have the 7 coefficient, I have the plus 12, and I have this first term squared. So one way to look at this is I have this chunk or this group of things. So I'm going to change 1/2 x plus 7 to an empty box. And that's going to seem a little strange. But when I do that, now it looks a little more doable. I have this empty box squared plus 7 times the box plus 12 equals 0. But I already solved this equation, except instead of the box, I had an actual x, the variable x. So when I solved this already, and I got the solutions -3 and -4. So in this one, the solution was 4x. In this one, the solution is going to be for what that box is representing. So this means we already solved this, and I got that instead of x, I'm using this box, -3, and it also equals -4. So this whole chunk of stuff, I've replaced it with a box because then it's just a quadratic, and instead of the x, I just have the squares. So again, I have the solutions for that, -3 and -4. But my whole boxed in representation here was this 1/2 x plus 7. So now I'm going to plug 1/2 x plus 7 back in because that's what that box is actually representing. So that's going to give me this new equation, 1/2 x plus 7 equals -3, and 1/2 x plus 7, again, equals -4. So I drew that box in to represent this chunk of stuff, kind of like to simplify it so I don't have to look at this messiness yet. Then once I get the solution for that chunk where I have the box, then I can replace what I kind of substituted the box in for. And then I have these new equations. So from here I can just continue solving. So on the first one on the left, I would subtract 7 from both sides and get 1/2 x equals -3 minus 7 is -10. Then I can just multiply both sides by 2 and get my solution of x equals -20. Or on my right-hand equation, subtract 7 from both sides, I get 1/2 x equals -4 minus 7. So -4 minus 7 is -11. Then multiply both sides by 2 and get my other solution of x equals -22. So this seems like a strange way of solving this complicated equation. However, once we recognize that I can replace the repeated piece, so this repeated piece, I can just substitute something simpler in there. And then it just looks like a quadratic, which we already had a solution for. So that repeated piece, I had a solution for what was x over here in the first, represented as something else here in the second, and then I substituted what I represented the box with in the beginning. So 1/2 x plus 7, and then I get my solutions for x. So what this is typically called is a U substitution, and you could call it anything. You could call it a T substitution, a Y substitution, whatever. You could plug any variable in there. U substitution is pretty common, and what that would mean is in the beginning up here I would have said let U equal 1/2 x plus 7. Then I would rewrite my equation. Now that this whole thing equals U, and so does that, it would become U squared plus 7U plus 12 equals 0. Then I would just solve that, since that's a regular quadratic, but we already solved that over here. And I would get these two solutions. U equals -3, U equals -4. Once I have a solution for U by itself, then I can re-plug in what I had let U represent in the first place, and then solve for x. So U is a temporary substitution to get a substitution or a solution for U itself, and then again replace it with what it had represented to get the actual solution or solutions for x. Okay, so I'm gonna walk through two more examples with you so that you can see this U substitution again and try and get more comfortable with it, and then I'm going to have you stop the video and do problems 3 and 4 independently. So let's look up here at example 1. I have x plus 2 squared plus 4 times x plus 2 minus 5. So let me back up and read this. For each of the following, first determine the repeated section in the equation that should be replaced using a U substitution. Then solve the equation completely. So in this first one, the repeated section, what we see being repeated is x plus 2, x plus 2. So that chunk or that piece is being repeated. So let's make the substitution for U. Let U equal, so first we just explain what we're going to be substituting U in for, x plus 2. So once we do that, now I'm going to rewrite this equation. Since now U is representing x plus 2, then right here instead of x plus 2 squared, I can just write U squared plus 4, and instead of x plus 2, it would be 4U minus 5 equals 0. So now I just have a quadratic. This is something we're familiar with. This is something we have strategy for, and we can solve this by factoring. So I'll use my diamond game, plug in my -5 here, 4 down here, and I'm looking for two numbers that multiply to -5, add to -4. So that would be +5 and -1. And those are going to help me build my two factors. So that would be U plus 5 times U minus 1 equals 0. This gives me two solutions for U. U equals -5 and U equals +1. So in the original equation there are no U's. We need to solve for x. We temporarily let U equal x plus 2 until I could get a solution for U. Now that I have U by itself, I can plug in x plus 2 back in and get my actual solutions for x. So instead of U equals negative 5, x plus 2 equals negative 5, and x plus 2 equals 1. On the left equation, subtract 2, and I get my solution x equals negative 7. My second one, subtract 2 from 1, x equals negative 1. And these are my solutions for x, which is the goal here. We temporarily substitute u in, get u by itself, replug x plus 2 back in, and then we have our solution. All right, let's look at number 2. So I've got a lot going on here. Let's first look for the repeated section that we can make the u substitution for. So this one, we see 5 times this big section x squared minus 1/7, all divided by 6, plus x squared minus 1/7 divided by 3 equals 1. So we see this repeated piece right here. That looks a little complicated. So let's substitute u in for that. So we'll make this u substitution. U equals x squared minus 1/7. Okay, so once I do that, I'm going to replace this whole thing and this whole thing with the letter u. So we've got 5 u over 6 plus x squared, nope, that whole thing, u over 3. This is a much more manageable problem. So here I've got a couple of fractions. We will use that fraction buster method here. I'm going to multiply everything by 6 to get rid of that first fraction. So in doing so, I've eliminated the first fraction, but I need to multiply everything by 6. So this one cancels. That was my intention. And I have 5u plus 6 times u over 3 equals 6. Luckily, this second fraction here, 6u over 3, the 6 and 3 reduced to 2. So I have 5u plus 2u equals 6, or 7u equals 6. Then I would divide both sides by 7 and get u equals 6/7. Okay, so I have a solution for u. That is not my final answer. Remember, we were solving this original equation for x, but I do have u representing x squared minus 1/7. So now I will plug x squared minus 1/7 back in for u, and instead of u equals 6/7, whoops, it is x squared minus 1/7 equals 6/7. Okay, now I can solve for x. So the first thing I'll do here to solve, I would need to add 1/7 to both sides. So add 1/7 here, add 1/7 here. Luckily, they have the same denominator, so I would just get x squared equals 6/7 plus 1/7 is 7/7, or 1. So x squared equals 1. I'm running out of space here. Square root both sides, and you'll get your final answer of x equals the square root of 1, which is 1, or negative 1. Don't forget those negative possible square roots. So x equals positive or negative 1. That is my final solution for this one. So that's where I'm going to stop. I'm showing you examples, but I do want you, whoa, not cool. I do want you to try these two on your own, 3 and 4. And then I'm going to take a look at these. Once you're done, please submit this to Schoology so I can look at it and make sure you guys are on track on this new subject of solving a little more complicated equations using these u substitutions. So again, I'm going to stop here, use the next 5 minutes or so to go through these, and when you're done with 3 and 4, upload to Schoology. All right, I will see you next time.